Hey everyone. So in this video, we're just going to do a couple of examples of probabilities with, and this is theoretical, not experimental. We're going to revisit what we looked at in the warm-up, which is we have a couple, they decide they want to have 3 children, and we're going to create, I'm going to revisit that sample space. So just a reminder, we could have 3 males. We could have male, female, male, 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 female, or male, female, female. We could also have female, 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 male, female, 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 male, and female, male, male. And the order of these doesn't matter. It's just what comes to the top of my head first. So we want to know, so using the sample space outlined in the warm-up, which I just rewrote down here, what is the probability that this couple has 3 children that are all male at birth? Okay, now this one you might have been able to do in your head. All male at birth seems to just be this scenario out of the total. So to find the probability, we're going to take the definition of the probability, the theoretical probability, is the number of events that we're looking for. In this case, there's 1. So the probability that that all 3 children are male is 1 over all the possibilities. So we have one scenario that is the favorable outcome, what we're looking for, that's called the favorable outcome. And then we have the whole sample space, which is all the possible outcomes. In this case, there's 8. So the probability that all 3 children will be male is 1 in 8. So now we want to know, what is the probability that 2 of the children are female at birth? Okay, so we want to get rid of the highlighting here. Oop. So what is the probability that 2 of the children are female at birth? So now I have to go through and find all the scenarios that have 2 females. So there's 1 here, there's 1 here, there's 1 here. Now I might not have been able to count that as easily if I didn't have my sample space listed out. And so the probability of 2 females is 3 out of 8. And then this last example is going to have us talk about the probability that at least one of the children is male at birth. Now, luckily, we already highlighted 3 that have 1 male in them, because this one was exactly 2 females. Now we're talking at least one male. So this is going to be the probability that at least 1 male, but then we could also have the probability that there's 2 males, and then also the situation where all 3 are male. So we need to count up all of these. So anywhere I see 1 male or 2 males or 3 males, I already have 1 male highlighted. Is there any other one that has 1 male? Nope. So now let's highlight 2 males. There's 2 males here, 2 males here, 2 males here. And now let's highlight the 3 males, okay? So the probability here, and I'm going to write each one out. So for the 1 male, there were 3 out of 8. For 2 males, there was 3 out of 8. And then for 3 males, there was 1 out of 8. And altogether, that gave me 7 out of 8. When we add fractions, we keep the denominator the same, we add the numerator. We have to have the same denominator in order to add the fractions. Now, there's an idea that is really helpful when calculating more difficult probabilities, and that is the idea of a complement. Now, all the different probabilities have to add up to be 1, right? All of these have to add up to be 1. There's one piece missing here. There could be, and I'll do this in a different color, the probability of there being no males. And the probability of there being no males is 1 out of 7. That's this situation where we have all female. And when we add all of these together, then we get 8 out of 8, which is 1. And so sometimes it's easier to calculate the complement of what I'm looking for instead of what I'm actually looking for, okay? So notice that if I had found the probability that there are no males, that would have been easy for me to calculate. It's this value right here. It's 1 out of 8. Now the probability that there's no males plus the probability that there's at least 1 male has to add to 1, because no males is the opposite of having at least 1. And so what I could do is, if I know this value and I'm looking for this value, I can just solve this equation. So I'm going to subtract 1/8 from both sides, and the probability that there's at least 1 male is 1 minus 1/8, which is 7/8. And so we get the same value no matter what. But I think this technique is much easier to do in our heads, whereas this technique up here required us to list out the sample space and then figure out exactly how many fit each of these scenarios. So something to think about. We'll definitely talk more about problems like this when we get to advanced probability. I will see you in the next video.